In number one, we want to simplify this square root. So we're going to use a trigonometric identity. First, underneath the square root, we're going to factor out 9, so that inside we're left with 1 minus cos squared theta. And then we're going to replace 1 minus cos squared theta with sine squared theta. So this is equal to the square root of 9 sine squared theta. And now in this range, 9 sine squared theta is positive, so we can simply pop off this square root, and this is equal to 3 sine theta. This is the type of manipulation that we do, or simplification that we do, when we do a one of our trig substitutions. So this is typical. And now in number two, we're going to do something similar to what we did in number one. First, we'll start by factoring out 9 underneath. And now we have a trig substitution. 1 plus tan squared theta is equal to secant squared theta. So this is the square root of 9 secant squared theta. And in this range, secant theta is positive, so we can just pop off that square root and we get 3 secant theta. So the simplification is what we do when we do a trig substitution with using tangent theta. In number 3, it says we want to express cosine theta in terms of x, and here's what we have. 5x is equal to 3 sine theta. So first let's solve for sine theta. So sine theta is equal to 5x over 3. And using this, we could get expressions for other trig values like cosine theta in terms of x. And the way we were doing this is we were drawing a triangle and putting theta in our triangle. And theta is an angle whose sine is 5x over 3. Remember, sine is opposite over hypotenuse. So the opposite side we'll label with a 5x and the hypotenuse label with a 3. Using the Pythagorean theorem, 25x squared plus this side squared is equal to 3 squared is equal to 9. So this side is, from the Pythagorean theorem, 9 minus 25x squared. All right, so now using the triangle, we can get other trig values of theta. For example, cosine theta is equal to adjacent over hypotenuse, so that would be square root 9 minus 25x squared over 3. Sometimes when we do a trig substitution, before we convert back to x, our solution is in terms of sine 2 theta. So let's suppose that we want to figure out what sine 2 theta is, given that 5x is equal to 3 tan theta. Okay. All right. So we're going to create a triangle like we did in the previous example. First, let's solve for tangent theta. So we have tangent theta is equal to 5x over 3. And we can get other trig values of theta, just like we did before. We had this triangle. We put theta in here, and we said that, well, in this case, 5x over 3 is tangent theta. This is opposite over adjacent. So I am going to label the triangle like this, 5x for opposite and 3 for adjacent. And then this third side, using the Pythagorean theorem, is 9 plus 25x squared. So now we can get other trig values of theta, but here we want sine 2 theta, not a trig value of theta, but a trig value of 2 theta. Okay, so what we're going to do is use a trigonometric identity. Sine 2 theta is equal to 2 sine theta cosine theta. All right, we did that little identity because we could figure out sine theta and cosine theta using this triangle. All right, so let's finish that off. So this is 2 times sine theta is opposite over hypotenuse, so that's 5x over square root 9 plus 25x squared. And cosine theta adjacent over hypotenuse, so we have 3 over square root 9 plus 25x squared. All right, we might as well just multiply those denominators, and let's just multiply those numerators as well. So in the numerator we have 2 times 5 is 10 times 3, we have 30x. And in the denominator, multiplying these two square roots, we have 9 plus 25x squared. In number 5, we have 4 minus x squared underneath the square root. So this fits into the following form. If we have something of this form, square root a squared minus u squared, where a is a constant and u is some expression involving x, then we do the substitution u equal a sine theta. And du is equal to a cos theta d theta. And theta is between minus pi over 2 and pi over 2, but we don't have to be concerned about that. All right, so let's start doing our substituting. Okay, so first, all right, so we're doing the actual substitution that we're doing. In our case, x and u are the same. Here's a squared, 2 squared, so a is equal to 2. So the substitution that we're doing is x equal 2 sine theta. And dx is equal to 2 cosine theta d theta. All right, now we're ready to do an exact substitution. First, let's substitute x squared. So we're going to square this, and we get 4 sine squared theta. I'll put that up here. Okay, and underneath the square root, we have 4 minus x squared. Again, x squared we just did. That's 4 sine squared theta. Now, for dx, we're putting 2 cosine theta d theta. All right, and now we're going to proceed to simplify 4 minus 4 sine squared theta. All right, so underneath the square root, we will factor out 4. And do our trig substitution, change this 1 minus sine squared theta to cos squared theta, and that's just so that we can take the square root. All right, so now let's take the square root. So in the denominator, we have the square root of 4 cos squared theta, so that's taking the square root, we have 2 cos theta. Let me just copy over this numerator. And here we have 2 cos theta. All right, so now we're ready to just cancel those. And we're left with 4 times the integral of sine squared theta d theta. All right, so we know how to integrate sine squared theta. We use our trig substitution. So that's 4 times, okay, here's the trig substitution, 1/2 1 minus cos 2 theta. I just took the 1/2 on the outside. All right, we can just integrate this right away. Here we have 4 divided by 2, that's 2. And here we have theta minus, this is the derivative of sine 2 theta, but we're missing the 2, so we'll put a 1/2 here. Okay, sorry. We are integrating, so we have integrated. Let me just remove that integral. Okay, so, okay, now we have integrated, so that's 2 theta minus, and here we have 1/2 sine 2 theta. And now we want to convert back, so here's the point where we draw our triangle. All right, let's go back to this original substitution. Let me solve for sine theta. So we have x over 2 is equal to 2 sine theta. Sorry, x over 2 is equal to sine theta. All right, let me write this down over here. X over 2 is equal to sine theta. And underneath I'll draw a little triangle. So we can get other trig values of theta. That's opposite over hypotenuse. So by the Pythagorean theorem, this side is 2 squared 4 minus x squared. And we can get, at this point, cosine theta, sine theta, tangent theta. But we want sine 2 theta. All right, so we're going to use a trig identity like we did in the previous one of the previous problems in this practice set. We're going to replace sine 2 theta by 2 sine theta cosine theta. Because we have no problem using the triangle, we could find sine theta and cosine theta. All right, so let's do that. So here we have 2. Instead of, for theta, we're going to substitute arc sine x over 2. If we solve this for theta, we get theta is equal to arc sine x over 2. All right, so that's what we're putting for theta. Minus 1/2 times 2. Okay, those will cancel. Sine theta x over square root 4 minus x squared. Sorry. That was tangent. Let me put in sine theta. Sine theta is just x over 2. And cosine theta adjacent over hypotenuse. Over hypotenuse 2. Okay, so that's our solution. We should really just cross off these 2's. And we could simplify a little bit, but I'm going to leave it like that. Number 6, we have a square root of the following form. This is of the form square root u squared minus a squared. So here the variable comes first. That's why I put u squared first here. U is some expression involving x. In this case, u and x are the same. All right. And a is equal to 2. 4 squared is 2 squared. The trig substitution that we do in this case is u is equal to a secant theta. And du is equal to a secant theta tangent theta d theta. All right, in our case, x is equal to u, so and a is equal to, a squared is equal to 4, a is equal to 2, so we're doing the substitution. X is equal to 2 secant theta. And dx is equal to 2 secant theta tangent theta d theta. Okay, so let's start. Let's do our substitution. And we have here underneath the square root x squared. This squared would be 4 secant squared theta minus 4. X in the denominator, that's this, 2 secant theta. And for dx, we're substituting this, 2 secant theta, tangent theta, d theta. Let's immediately simplify by crossing off the 2's and the secant thetas. Okay, now let's go underneath that square root, and we're going to factor out the 4. And there we have secant squared theta minus 1. And here we have tangent theta. All right, secant squared theta minus 1, that's equal to tan squared theta. So underneath the square root, we have 4 tan squared theta. Let's right away take the square root of 4 tan squared theta, and we get 2 tan theta. And then we have this tan theta, d theta. All right, so we end up with, I'll bring the 2 outside, we end up with tan squared theta. Here, a trig substitution would enable us to do our integral. Tan squared theta is equal to secant squared theta minus 1, and secant squared theta is an exact derivative, so that's why that'll help. All right, so here we have secant squared theta minus 1 d theta. All right, secant squared is the derivative of tangent, so now when we integrate this, we have 2, the integral of secant squared theta, that's tangent theta, and the integral of 1 is theta. All right, so here's our integral expressed in terms of theta, and now we want to switch over to x. So let's go back to our original substitution, and we have x, if we solve for secant theta, x over 2 is equal to secant theta. So let me copy that over here. X over 2 is secant theta. All right, let's draw a triangle. Remember, secant is 1 over cosine. Cosine's adjacent over hypotenuse, so this is hypotenuse over adjacent. So if I put theta over here, I'll put x for the hypotenuse and 2 for the adjacent. All right, now this side, using Pythagorean theorem, is the square root of x squared minus 2 squared, x squared minus 4. All right, so now we have no problem filling in tangent theta. Tangent theta is this over this, opposite over adjacent, square root x squared minus 4 over 2. And theta, well, we just solved for theta here, and we have theta is arc secant, x over 2. Okay, so there we have it. Our final answer, let's cancel these 2's, would be square root x squared minus 4 minus arc secant x over 2.